Okay, good morning everyone. How are you? After seeing this video again, I should really consider, improving my acting skills, but okay, next time. Okay, today we are going to talk about Jenkins, how you can organize your Jenkins build system for having a efficient and scalable CI. First of all, let me understand how many people are using Jenkins here. Whoa, yeah, quite a lot of people. That's nice. Jenkins is a complex system, and I always refer to it as a blank page. So whenever you get your first Jenkins instance, it's like completely empty, can do barely a couple of things, and then all the abstraction and all the functionality come over with plugins. Today we'll show you a little bit the history that we have in Camunda with that. We have been using Jenkins since quite a long time. We have been using it extensively, and it has evolved quite a lot together with our company. My company Camunda, just to give you a quick introduction about what we do, it will help you to have some more context. My company is developing open source software for workflow automation. Basically what it does is that it creates a software called the Camunda BPM platform that allows you to describe complex workflows in a graphical way, and then you can automate this workflow. So for each step you can define, for example, send an email, make an API call, you name it. It's very extensible and it's very customizable to your company needs. What we do is that we have an open source version that you can download and use it for free. Feel free to do it at camunda.com. You can download it, use it, redistribute it as much as you want, and we have our open source release twice a year. On top of that, our enterprise customer have access to patch releases, for example, that fix security fixes. They have additional also support and consulting from our team. And on top of that, of course, their tickets have priority over the open source one. Right now, we support over 7 database vendors, 4 different Java vendors, and 7 different server runtimes. Our CI is quite complex. We need to guarantee to our client that our integration with their environment is working 100%. For this reason, we always value code quality. We need to make sure that all this possible combination of database vendors, Java vendors, and server runtime are working correctly. In terms of our CI, we started quite a long ago, and we like to define our CI in different stages. So we started with CI 0.5 when the company was really small, around 10 employees. Then we evolved with CI 1, 2, 3, 3.5. That's where we are today, a company with over 100 employees. We will see together which solution we implemented at the beginning and why, what did we learn from that, and what did we implement for the next iteration and how the next iteration went. So CI 0.5, I will spend a very short time on it. It was really the age of bare metal. That's how we called it internally. So we were just a couple of developers. We just needed a working CI/CD system that could test and release our software. So it was a single Hudson instance, not even Jenkins, running on a machine co-hosted in our office. Everything was provisioned manually. All the jobs were defined manually. All the environment were defined manually. And as you can imagine, this works when your team is around 4 people and your software is relatively small, but this really doesn't scale out. So we started hitting almost immediately problems, mainly in the topic of reliability. So the single machine was Jenkins master and slaves. This means that it was running the jobs and scheduling them at the same time. So whenever there were many jobs running at the same time, our interface would become unresponsive, for example. Scalability also from the point of view of jobs queuing up. So our queue was always really long. It was taking always a very long time. And from the point of view of maintainability, the whole thing was just terrible. We really had to manage everything by hand. And whenever you need to change the same thing in all the jobs that you have, you can see how painful this can get. CI1 was already a big step forward. This is what we call the age of virtual machines. So virtual machines for us were working quite well, and actually they covered our use case very well. We wanted to have isolated environment, one for each database and one for each server environment that we supported. And what's the best way to do that in an isolated fashion? At the time it was virtual machines. So as you can see from this slide, we had a master connected to 8 slaves. Each one of them was dedicated to an environment that we supported. And each one of them was a different virtual machines. This started working okay. Number of jobs started increasing, and for a while we adopted this solution successfully. The problem started when our number of jobs started increasing more and more. So we started to arrive to 1,000 jobs. 1,000 jobs managed manually are really, really painful. especially when you need to change something in each one of them. You can script it, of course, but still, it's a lot of time. At this point, we had around 4 Camunda versions. On top of that, different community projects, websites that we were maintaining, and some operational tooling that we were using internally. The main problem with this setup was that we always had one slave per environment. So if I wanted to test MySQL with all the possible versions, I had only one slave that could do that. Same would go for DB2, same would go for PostgreSQL. This thing was really becoming the bottleneck for us. So jobs were queuing up because there were not enough slaves able to take on the load. What the problem CI1 had? The main problem was maintainability. Again, jobs were managed manually, configuration was managed manually, and all the environment were managed manually. Resource isolation was still an issue. At the end, you always had one instance per database, so one virtual machine per possible environment, and reproducibility became more and more of a problem in this case. So our devs and QA were really struggling to reproduce issues that we had in the CI in their local environment. They had to follow these huge wiki pages trying to describe to them how can you configure your DB2 database on your local machine. This was really painful for them. And it was extremely complex to recreate an issue that you had in CI in your local environment. As a quick anecdote, I'm not saying that you should do that, but we used to have a huge Excel sheet that would say, okay, each virtual machine is exposing these ports and they're reserved to a particular virtual machine, so you should not bind them again. As you can imagine, the more environment we started supporting, the more this huge Excel table was growing and growing. And we realized really soon that this was not the way to go. CI2 was the so-called age of containers. So we realized at the time containers were just coming out. Docker was still in a very early version, was still quite buggy and had its own problems. But we figured out that indeed containers were the best use case for us. We didn't need a full virtual machine to run a database. We just needed a couple of processes isolated from each other. Isolation was, of course, priority. For us, another thing that we were really committed to do was infrastructure as a code. During CI 0.5 and 1, we saw how painful it was to maintain all this kind of configuration and jobs manually, and so we committed to do infrastructure as a code. Let's try to describe everything that we can as a code. And let's make it easy to support new environment. Whenever I want to try if a new environment works or not with my product, I should be able to do that efficiently. I should be able to do fast in a matter of minutes, not in a matter of days. We wanted, of course, resource isolation. This is why we continued working with containers. And on top of that, also scalability and container orchestration. This is why we started having a look at projects like Docker Swarm, at the time in which Docker Swarm was still not included in the Docker binary. So I'm speaking about a couple of years ago, yeah. There's also another important thing that we started to struggle with was resources. So at the time, in the age of virtual machines, we had a couple of servers that we were co-locating in a data center. And while this was working okay, it created a lot of problems. When a disk gets broken, somebody has to go and change it. When you want to deploy new hardware, you need to buy the hardware, ship to your office, configure it, ship it to the data center, and then install it. It doesn't take 1 week. Sometimes it takes 2-3 weeks to get the new machine up and running. And on top of that, server equipment is really expensive. So we started thinking, okay, can we do something different this time? Do we really need all the capacity that the data center needs? Do we really need these kind of things? And then we started, maybe we can do it differently. Maybe we can do it cheaper. Maybe we can do it in a more convenient way. And this is why we started using commodity hardware for that. We didn't need the powerful server hardware co-located in a data center. And then we started buying basically commodity hardware. And this was like a picture of the first cluster that we created. So we started buying Tower PC because they're cheap, they're efficient, they work well. They have a replacement part. You can just go to your local electronics store and find a new hard drive. It takes a couple of hours to get it. And it works really well. It worked really well for a long time. So right now you see the cluster is quite small, just 4 machines. We ended up, whenever we need a new capacity, we would just go to the hardware store and buy a new Tower PC. That's it. You plug it in the cluster and it works. It worked quite well. The combination of software we were using for that was Docker Swarm and Consul. Docker Swarm for orchestrating containers inside the cluster, and Consul to do service discovery, basically. This worked well for many years. It worked quite well because, as I said, it was really efficient from the point of view of cost. As soon as the capacity was growing, it was very easy to add new resources to it. But on the other hand, as the company was growing, we started having 50 employees, 60 employees, and so on. It started as well starting its limit. So we never considered running our own data center, if that's what you're thinking. On top of that, we got out of the box reproducibility for our devs and QA. I don't know if you're familiar with the Portainer project. Basically, it's a project that allows you to create containers, and basically your dev and QA engineers to just get an endpoint where they can reach their MySQL database, which will be in the same version that is running on the CI. So they didn't have to configure anything locally anymore. They could just ask Portainer to provide a container for them, and then out of the box they would just get an endpoint to test against. These work really, really well, and our QA engineers in particular really were glad not to have to follow these huge wiki pages for configuring the database locally. One anecdote that you should know about, at a certain point they asked us to basically work on Microsoft server. All our servers were Linux servers. Containers on Microsoft were not really a thing. So, okay, how can we do that? This is going to be a problem. With virtual machine, it was easy. You just create a virtual machine with Windows inside, and that's it. Containers a bit more tricky. This is a funny workaround that I always like to tell, but we're not proud of it, but it works. So we were creating like virtual machine images using Packer or Chef, and then basically we're spawning a Docker container with QEMU inside that would create your virtual machine with Windows and start your SQL server. Terribly slow, but works. So for that time, this was the solution that we adopted basically to test Microsoft SQL Server inside our CI. But as I said, it's always a process of learning. Like we learned a lot even from CI 0.5, then even more from CI 1, and right now even more with CI 2 because it was our first experience with container. And as I said, at the time Docker was just getting started. The lesson learned with CI 2 were many, really many. It was really important. It was really a necessary step before going into CI 3. We evaluated different things. In the beginning, there were big discussion about what should we do. Should we download packages directly from the repository manager? Should we host our own binaries? Is it fine to run more than one process inside the same container? Should we rebuild our images periodically? These are all lessons that we learn. And now for our CI3, for example, we try always to rebuild all the images that we have periodically to make sure that all of them can be rebuilt at the same time. It was also nice to have a unique interface to build Docker containers. Most of you, I guess, do just Docker build, but this is not really our use case, for example. If you are running containers with, for example, DB2, the whole thing gets much more complex than a simple Docker build. And problems. So company is growing, more and more people are joining, and yeah, the problems start to come out. Maintainability, still an issue that we didn't manage to fix until now. So the whole thing was working quite okay. So we had found a strategy to write our own jobs, and it was working quite well. So from a jobs point of view, we were covered. Right now, the problem was Jenkins. So updating Jenkins plugins, and in particular the Docker plugin for Jenkins was really, really hard. It was difficult to test. It was really complex to do because you always had to consider, okay, what's my Docker version? Is my plugin compatible with it? Is my Jenkins compatible with it? What's the operating system of my physical machine offering? And so on. And on top of that, the requirements started to increase. Right now I'm speaking about our main product, so the Camunda BPM platform, but since then Camunda has grown a lot. So there were more and more Jenkins running, one for every different project that we had, that required attention and required resources. Scalability, still a problem. As I said, it's easy when you have commodity hardware to just buy a new tower, but you cannot do that forever. It doesn't really scale that well. And of course, you're still paying for electricity even when you're not using that hardware. We wanted something more flexible, something that would allow us to work in a scalable way and in a smart way, without wasting money, without wasting resources, without any purpose. Resource allocation was still a problem. Those version of Javas that we were using, just to give you an idea, we just finished supporting Java 6 in November last year. And Java 6 is end of life since like 3 years. This means that whenever we add a new environment to our Camunda VPN platform, whenever we add a new supported environment, we need to do it for long. And as you might know, Java started supporting really containers from one of the later version of Java 8, and we are still at this moment supporting Java 7, for example. So Java was a problem, so we had to tackle that as well, setting always hard limit and making sure that Java wouldn't try to get over the limits that the container was specifying. And then we said, okay, you know what, maybe we should think about CI/3. This was a hard stop. Said, okay, or we continue buying commodity hardware everywhere and apply patch on top of patch, or we should do something new. And this is when the idea of CI/3 came out. So our main problem was, of course, scalability. We said, okay, maybe we should try this thing that everyone is using called the cloud. We want a more advanced container orchestration on Docker Swarm. Okay, maybe we should have a look at this Kubernetes everyone is talking about. And we wanted to reduce maintainability. At the end, we didn't care about the physical machine. All we cared about was that our jobs were running, that our CI was stable. And so we said, okay, let's try to use a managed service like Google Cloud. At the time, AWS was still not offering a managed solution for Kubernetes. Still, this is not all pink glasses as it's here. So nothing. I mean, everything looks beautiful, but it took us a lot of time to migrate to it, first of all, and to build experience on top of it. But when we sat with our team to think about, okay, how should we structure CI/3, we said, okay, let's try to do it in an organized way. What's the philosophy? What's the pillars that we want to have in our CI/3? The first idea is that this time, everything should be configured as a code. So we always managed to have the jobs as a code, but we didn't manage to have the Jenkins configuration, the plugins as a code. So we wanted really to make the next step and have everything as a code. This was really important for maintainability mainly, and it was really important to make things more organized as well. We didn't want anyone to go and change the Jenkins configuration by hand, and then as soon as you restart it, everything is broken again. We wanted to have one place where your configuration is stored, and after that, if you change something manually, you need to know that later in the same day, things will not work again. Reusability. As I said, we started having more and more projects inside Camunda. Camunda VPN platform is our biggest one, but it's not the only one. And also these other projects started gaining more and more traction. And the problem with CI2 was that every different Jenkins was configured in a different way. Was configured by a different person in a non-standard method. So we said, okay, let's try to make things more homogeneous. Let's try to have one way of configuring our Jenkins, one way of configuring our CI, and let's apply it everywhere. We want to be able to move a configuration from one Jenkins to another if we need to, and do it easily, in the same way all other Jenkins works. We don't want snowflakes anymore. As I said, no more snowflakes. Configuring Jenkins in a custom way is always maybe the easiest way if you want a hard-coded configuration, but then you will have a lot of pain whenever you have to update something, be the Jenkins version or the Jenkins plugin, for example. Maintenance and upgrades should be low effort. We didn't want to spend much time upgrading Jenkins and upgrading the plugin. It should be a process that it's easy to do, that we can do regularly, because we want to try to keep up to date and not lag too much behind. But it's not something that should take you a day to update one Jenkins. And you should be able to do it for all the Jenkinses at the same time in a time-efficient way. Before, with CI2 and before, this would take really a long time. Testing all the possible corner cases and use cases was becoming really, really difficult. And this is why we also focused on maintenance and upgrades. So we started, as I said, working with Kubernetes and our cloud provider, Google Cloud. Jenkins started offering this plugin called the Kubernetes plugin that basically integrates Kubernetes with Jenkins, or better, Jenkins with Kubernetes. The advantage of this is that you don't have limitations anymore in terms of resources. You want a server, you want more resources, you ask for them to the Google Cloud, you use them for the time of your job, and as soon as your job is finished, that machine will be destroyed and you will stop paying for it. So it's really efficient also from the cost point of view. In terms of resources, it was really nice because it made it possible to get bigger server for a fraction of the price. So just imagine that the Camunda VPN platform at the moment, if I try to compile it on my laptop, which is quite like not brand new, but almost, would take around 50 minutes to 1 hour to compile and run all the tests. So this was the same. In our CI, it was taking exactly the same time. And this was really hard for our developers because they had a very long feedback cycle before even knowing if their commit was working or not. Right now, we are allowed to create servers with a 32 cores, run the whole build in 10-15 minutes, and our devs are much happier. Scalability. As I said, we didn't want to pay anymore for machines that we don't need. This was a problem in the data center. This was a problem later in the office as well. Right now, during the nights, our cluster might be quite small, 6 or 7 machines. During the day, we can go up to 150 machines. And everything happens on demand. You need something, you get it, you don't need it anymore, you stop paying for it, and the resource is deleted. We started also using the configuration as code plugin for Jenkins. Some of you might know that. It's a relatively new plugin for Jenkins. I think it's being developed since a year and a half or so, but it works really well. For us, configuring Jenkins inside container was also always quite complex. You always need to paste this XML file here and there. And a lot of people complain that YAML format is not a good format for configuration, but if you have done that with XML, it's a new word. I mean, YAML is really fantastic compared to XML. We got rid of so many custom Groovy scripts that were running on startup to configure our Jenkins. Everything now is done using the configuration as code plugin. So when our Jenkins boots, basically this plugin checks out the configuration that we provided, and then that's it. Jenkins is configured. The disadvantages, of course, is that it's still a young plugin. So we started working on it since the early stages with the mentality that we, of course, had to contribute back to it. And yeah, still, not everything is configurable using, it's called CASC, but it stands for Configuration as Code plugin. So it's quite a new plugin. Not everything is supported yet. Not all the plugins support it yet, but it works very well. It's still young, but very promising. In case you're going to use it, start with the idea that you will need most probably to contribute back at least a little bit. But now our Jenkins process was streamlined. Our way of configuring and setting up Jenkins was streamlined everywhere. And this was really nice and interesting. So right now, we didn't even have custom images anymore. We didn't need them. We don't need to have a custom image for every project with a different set of plugin or anything like that. We are using the image straight from the Docker Hub. What happens after that is that Kubernetes downloads all the plugins that we need using an init container. So this is a container that runs before your pod that can do some actions. In our case, it basically downloads all the plugins that we provide and downloads the exact version that we specify in the configuration. If the plugin is already downloaded, it gets skipped. If the plugin is not downloaded, it gets downloaded from Jenkins website. So at this point, we have all the plugins that Jenkins needs to have before starting. Jenkins starts to boot. And at this point, during the boot, the configuration as code plugin takes the configuration that we provided and applies it to our Jenkins. So at this point, we have a Jenkins up and running, perfectly configured with what we wanted. This was really nice and really interesting. As I said before, one of our ideas was that we wanted also our configuration to be portable across different Jenkinses. So for example, if you have 10 Jenkins and you have like your LDAP credentials set up, You want to do it, you want to put the configuration only once, and all of them will apply the same configuration. This makes our setup, as I said, easy to replicate, even locally. You can just do it on Minikube, because everything is downloaded on demand if it's needed. And it's portable and reusable. So if I change something in the configuration of Jenkins, I can port it to all the others very easily. It's just a copy-paste. Environments. As I said, we had a lot of environments. So at this stage, we have a Jenkins that is up and running, is configured correctly, but it's empty. There are no jobs, there are no environments. In our case, as I said, we support different environments. So it might be different version of databases, different version of application server, you name it. In this case, the approach we went for is creating one Git repository for every vendor. So we have one Git repository for all the PostgreSQL version that we support, one Git repository for all the MariaDB version we support, and so on. This repository keeps inside the Docker file that generates the image, the configuration file for the application. So in some cases, we need some custom configuration files that we need to put inside the container, and we need some tests. So our Docker image is always tested after they're built to make sure that they will work in the CI. This repository is shared across versions. So as I said, all the version of PostgreSQL that we support will be inside the same repository. This means that whenever you run, you try to support a new version, you just try to build a new container with the same configuration file, and most of the time it works, to be honest. It forces us to rebuild all the images periodically. We had this problem in the past, for which we were building Docker container that would download the package from a Debian or Ubuntu repository, and all of a sudden that package was gone. So something that you could build 2 years ago, you cannot rebuild it today, for example. This forces us to rebuild everything every single time and make sure that everything works, and that if we need one day to change the configuration of an environment that we supported, that we are supporting since 2 years, we can still do that. And as I said, reusable code. This was one of the main points of CI/3. How does it work for jobs? As I said, we have quite a large amount of jobs, around 2,500 at the moment, just for Camunda EPM platform. And we started using the Job DSL plugin. Some of you might be familiar with that. Job DSL plugin works quite well, but it always it will bring you up to a certain extent. You still don't want to manage 25,000 DSL files manually, because no matter if you're a script guru or anything, it's really complex and it's really difficult. So we've wrote our own Groovy project over the years. This is a project that's been ongoing since CI2 that basically allows us to generate dynamically these DSL files, and they define for us basically the whole schema. So I can say whenever I want to add a new Postgres version to our CI, I just need to add it to our list, and this will automatically generate the new job and find out automatically all the dependencies from previous jobs, for example. This makes extending jobs much easier, and whenever you need to apply the same change to different set of jobs, that's also quite easy. I don't know if you ever had the opportunity to change like multiple jobs in Jenkins, but going through the UI, it's really hard and takes a lot of time. Just to show you what's the situation today, this is something that also we had to build by ourselves. So this is a graph of all the jobs that we have for Camunda, the latest version, so 7.11 that is developed right now. Every dot is a different job, and every line is a different dependency. So this means that as you can see here, that this job will trigger this one, that then will trigger the rest of the graph. And then basically every commit that our developer pushed to Git can trigger a different branch of jobs. It's possible that even one commit needs to trigger the whole tree. This doesn't happen often, but especially when you need to backport changes to previous versions of Camunda BPM, it's something that could definitely happen. So back at where we are today. So right now we are running around, as I said, 2,500 individual jobs only for the Camunda BPM platform, so without counting the one for the other projects. around 22,000 builds in the past month, and right now we have around 19 database supported, 8 different Java versions, and 14 different application servers. You can imagine how testing all these possible combinations makes the metrics grow bigger, and consider that we keep supporting old version of Camunda BPM for a very long period of time. This makes the number of jobs grow and grow and grow. One thing that we focused on while building CI3 and 3.5 especially was autonomy. So we wanted our teams to be as autonomous as they could to create new things. We wanted our teams to be autonomous when creating new jobs, autonomous when changing a configuration. In the past, for CI2, CI1, and so on, every time they needed to change a Maven profile, they had to ping one of us and say, hey, please, can you change the Maven profile in this job? This, as the number of developers was growing, became quite challenging, and it just caused a lot of interruption. We said, okay, let's try to find a degree for which our developers can still modify jobs, create new jobs, and edit them. But on the other hand, we want to maintain control from the other side of the view. What we do today is that we found a middle ground. So my team basically manages the Jenkins. So we manage Jenkins upgrades, plugin upgrades, and so on. On the other hand, the team manages all the job. So the teams is responsible for the jobs that it's running, for their dependency, for their configuration, and so on. It's always about the right degree of trust. This depends a lot on your company. In our case, what we do is that our developers are not Jenkins administrators, so they're not able to change the Jenkins configuration, and they're not able to access all the credentials. So whenever they need to access a new credentials, because they need to push on Docker Hub, to push to Maven Central, and so on, this is a change that someone from our team should do. But whenever they need to change a parameter in a job, yeah, sure, go on. Wrapping up the conclusions. So where we are today is the result of years of work. Don't think about trying to do it all by yourself in a week. It will take you much, much longer. And I really think that this trip that we made through CI 0.5, 1, 2, and 3 made things different for us. It let us grow a little bit in terms of experience, in terms of knowing what containers are, how virtual machine works, and so on. So every single step was an important step to go where we are today. What I can tell you is that in general, migrating to Kubernetes improved the quality and the speed of our development cycle quite a bit. The possibility to ask resources and ask resources on demand is just something that we couldn't imagine some years ago, but right now it's possible. And if you have this kind of use case, you should definitely try it out. The configuration as code plugin, if you're using Jenkins already, is the way to go, especially if you're starting a Jenkins project right now. Still keep in mind, as I said before, it is a young product. So it's a young plugin. There's like a year, a bit more than of work. So if you're using it, you need to have in your mentality that you might have to contribute back. But that's how open source works now. And always find the right degree of trust. Don't let the developers call you every time they need a single change, every time they need to change a single option. Let them do this work. It's something that they are best suited to do because they know how their software works, so they consequentially know better than you how it should be built and how it should be released. So let them do this kind of changes. Giving in general more autonomy to developers improved our quality of work a lot. We were not interrupted anymore every 5 minutes, every time we needed a new job or change a setting. So try to apply it also for your organization if that's possible. The degree of trust that you apply is not something that everyone can do. So try to find also the right degree of trust. Start small and then make incremental progress. That's how it worked better for us. Moving forward, we see that we will start offering to our developers also access to Kubernetes resources, like one namespace per developer, because they are developing more and more software that will run in the cloud. But this is something that maybe is a topic for CI4. Who knows? Thank you.